Okay, the next thing I want to show you has to do with transmission solenoids for the valve body, except these solenoids are the type that are either on or off. So I have a solenoid right here. Solenoids have to function three different ways. They have to work electrically, and I have a jumper wire. I have a jumper pack connected here, and has two terminals on this solenoid. I can come in with power and ground, and if you listen carefully, you should be able to hear the solenoid click when I connect power and ground to it. So here we go. So you can hear that click. You can use a scan tool on most transmissions to command the solenoid to turn on and off when the vehicle is parked with the engine not running. And you listen for that click. That click tells you that it's working electrically and possibly mechanically and hydraulically also. And remember, I said there are three ways that a solenoid has to work. So electrically, we run current through this coil of copper wire right here. It produces a magnetic field, which then either pushes or pulls on a spring-loaded plunger that is going to block or unblock this fluid passage right here on the end. Now that fluid passage would normally let hydraulic fluid, pressurized fluid, come through it and then squirt out on these four sides right here when the solenoid is off. But when we turn the solenoid on, it should block that passage and not let that happen. Well, there's a way that we can test to see if the solenoid is working like it should, and it's with this special tool here. And so I'm going to plug this solenoid in, grab a compressed air hose here, and what I'm going to do is connect compressed air to it, and it'll get real loud as it blows air through the normally open solenoid, and then I will connect power and ground to it, and it should shut off that airflow, and we should be able to see and hear that also. So here we go. It's going to flow through. Here comes the wires. So it totally stopped the flow of air, just like it would stop hydraulic fluid from coming through. So when we block the air or the hydraulic fluid from coming through, that fluid builds up pressure and it can push against a spring-loaded valve in the valve body called a shift valve, or whatever valve they want it to push against. Because the valve will have a spring pushing it in one direction, but as hydraulic pressure builds from the solenoid being on, it will push it back the other direction, or it can. So we have different solenoids to control the position of these valves, two-way valves, to control upshifting and downshifting of the transmission. So let's say in first gear the solenoid is off, but to shift to second gear we have to turn it on, which would run or apply pressurized fluid to the 1-2 shift valve, which would allow fluid to go to whatever clutch packs apply and hold different pieces of the planetary gear set to give us second gear. So we have solenoids that do that, and these solenoids are controlled by a computer. And that computer bases its decision of when to turn these solenoids on and off on all kinds of computer inputs. The two main, most important inputs are throttle position, where's your foot on your accelerator pedal, and the second one is vehicle speed. So it's usually throttle position versus vehicle speed, and then there's other factors involved as well. So I've got 4 more solenoids here. We are going to test each one of them and see if they are functioning as well as this solenoid that we just tested. So this one, I've worn off the letter. That's letter A. So here's letter B here. Let's check it for the ability to click first. So it's clicking just fine. Put it in the tester. Hold it in place with a clip. Connect the air to it. It's allowing air to come through just like it should. And now here's the electrical. So that one appears to be working as it should. Now let's try this one right here, C. Let's see if it clicks first. Yes, it clicks. Let's put it in the tester. Hold it in place. Hook air to it. Now hit power to it. Notice this one, when we hit power to it, although it clicked, it didn't seal off the airflow, and so that solenoid is not working properly. All right, let's check this next one here, D. Let's see if it clicks. There we go. No clicking. So if it doesn't click at all, then it's not working as it should on-off solenoid. So let's do this last one, E. It clicks. Hold it in place. Get some air to it. Here comes the power. Working like it should. So we have some solenoids that work like they should. We have one that didn't work electrically at all. We had one that worked electrically, but it bled air out, so hydraulically it wouldn't be working properly. And then we had another one that was working fine. So these solenoids have to function all three ways, electrically, mechanically, and hydraulically, in order for the transmission to operate properly. And once again, that's on these types of solenoids that are on-off solenoids. Now, if it's a pulse width modulated solenoid, then you can't test it this way. You have to use a scan tool and a pressure gauge on a lot of transmissions to turn pressure up or down. So if you think about these on-off solenoids, when they're off and fluid is flowing through it freely, there'll be no pressure buildup. But when they're on, we will get maximum pressure. Well, what if we didn't want maximum pressure, and what if we didn't want zero pressure? We wanted something variable in between. Well, that's where the pulse width modulated solenoids come in handy. And we can control, by controlling the pulse width signal, the duty cycle, how much fluid goes through it based on how long we leave the solenoid on versus how long we leave it off as we cycle it. Some of these are around 1,000 times a second. They're turned on and off, but they vary how long they're on versus how long they're off in that time period, and that controls the position of the valve inside of here that controls the flow rate of the fluid through it. And on later model, newer transmissions, they're getting away from these on-off only solenoids. Almost all of them are pulse width modulated, which means that we can control how quickly the fluid goes through and goes to those clutch packs to shift gears for us. And by being able to control how quickly the fluid goes through, we can also control how each shift feels. Is it a nice smooth shift? Is it a hard shift? Is it somewhere in between? We can actually adjust the shift quality, as it's called, by changing the pulse width modulation signal on the solenoids. Okay.